Hello and welcome to another video, this time on the October 2020 paper. It was done in October, by the way, because of the pandemic. If you're wondering why that is, it sounds a bit weird. It was just because very few people actually did this paper, and it had some hard questions on it, so that's probably a good thing. It really did have some rotten ones. I think that was almost deliberate. Anyway, let's get on with it. I've said question 2 here, but it is in fact question 3. Let me change that first. It's quite clearly question 3. And once again, it's about box plots, so there's a bit of a theme picking up here. Okay, so this is a group of 27 people, time taken to complete a puzzle. At least we haven't got any large data set stuff in here, it would sound like. Okay, so time taken in minutes for each group, member of the group was recorded, and clearly we've got a couple of outliers up here. We always denote them by a cross. Find the range in the times. Well, the range is going to be biggest, which is this outlier. You don't just ignore the outlier, minus smallest, which is 7, and so you get 61. I think sometimes students think that you can just ignore outliers. No, you just notate them, because they may well be good reasons why, maybe basically these people just weren't very quick at completing the puzzle. It doesn't mean you start ignoring them. They're still part of the data set. Find the interquartile range. Well, that's 25 minus 15. 14 is that? I can't count 14. 25 minus 14. And so that looks like 11 to me. Okay, for these people, the sum of x is this, the sum of x squared is that. So it looks like they are forcing you to learn the formula. Now, as I pointed out in my last video, they do give you this formula in the exam. It's down, where was it? Got it over here somewhere. There we go. See, they give you that one for standard deviation. So they do actually tell you that all you've got to do, and that is in part 2. So part C, the mean is simply sum of x over m. And so that's 607.5 divided by 27. And that comes to 22.5. And for D, standard deviation, they give you this formula, is sum of x squared over n minus the mean squared, which is sum of x over n squared. It's sometimes written down like this. I don't think it is in the formula book though, because in the formula book it looks like that. They just say x bar squared, which is another name for the sample mean. Okay, so we just plug it in, and we're going to be doing 17623.25. Make sure you can do these, because they're asking this a lot, aren't they? Divided by 27, and then we take away our previous answer, but let's put it in again just so we make sure we get the exactly right answer, and we square root it all at the end, and that gives us 12.1. Cool. Okay, then for part E, Taruni defines an outlier as 3 standard deviations above the mean. So this is a different definition of an outlier than what we're used to. Normally I'm used to 2 standard deviations from the mean, but they can define it however they like. So we take the standard deviation and times it by 3, and then we add on the mean, just so we can find out where we're going to start the outliers from. Now that equals 59, and so how many outliers are there in this data set? Well, as you can see, it's only this one which is above 59, and so I would say under that definition, 1 outlier. Just 1 outlier. And that outlier is the one at the top of the range. Where is it again? The one at 68 seconds. We've actually identified the outlier then. Okay, Adam and Beth also completed the puzzle in A minutes and B minutes respectively, where A is greater than B. When the times are included with the data of the other 27 people, the median increases, but the mean doesn't change. Interesting. Suggest a possible value for A and a possible value for B, explaining how your value is satisfied above conditions. Well, the mean was 22.5. And the median, let's just write this down, mean was 22.5. The median, what was that? Let's have a look. 20, So what we need is basically a value which is always above 20 so that the median increases, 2 values which are above 20, and 2 values which are either side evenly distributed around the mean. So let's say A equals 22 and B equals 23. That should keep the mean the same because one's above it and one's below it and they're symmetrical around it. But definitely if their 2 values are, and A's got to be greater than B, so I should have it the other way around as well. So I'll have that as 23 and that as 22. That way the median has to increase now because they also completed the puzzle and they are greater than the median, so that must bring up the median. Yeah. And so this seems absolutely reasonable to me. You could have any values though, like 21 and 24 for example. That's what's mentioned in the mark scheme, but you just need that a plus b is equal to 45. That way you're just going to have them, well, you just need them either side of the mean symmetrically. Yeah, that's the best way of looking at it, but above 20, that's all you need. Okay, right. Clearly you can say here, clearly the mean stays the same, as these values are symmetrical. I'm always careful with my explanations here about mean, but the median increases as both a and b are greater than 20. There we go. Cool. Okay, G. Without carrying out any further calculations, explain why the standard deviation of all 29 times will be lower than your answer to part D. Yeah? Explain why the standard deviation will be lower than your answer to part D. Well, your answer to part D, now what was, let me just check, calculate the standard deviation. Yeah, the standard deviation came to 12.1. What that's telling us is that on average, each item of data deviates by 12.1. But our two new items of data are only 1.5 away. Are very close to the mean, or much closer than 12.1, lying 12.1 away from the mean. Very close to the mean. So this should reduce the standard deviation. That's quite subtle. It's about actually really understanding what standard deviation is. Standard deviation is the average amount each item of data deviates from the mean. So that 12.1 is saying on average each item of data deviates by 12.1. And so as you can see, both our values here are way less than 12.1. They're only 1.5 away from the mean. And so that should reduce the standard deviation. Okay, hope that makes sense. Keep up the hard work and all the best.